Welcome to a short presentation about the GeoERA project Muse, which stands for Managing Urban Shallow Geothermal Energy. My name is Gregor Götzl. I'm working at the Geological Survey of Austria and I'm coordinating together with my colleague Cornelia Steiner the Muse project. It will be my pleasure to talk in the next approximately 10 minutes about the importance of managing shallow geothermal energy in urban areas and about the support in doing so from geological survey organizations. Geothermal energy is a strong all-rounder. It is one of the few renewable energy sources which may provide electricity, heat, cold, and energy storage at high level of efficiency and stability. Except for producing electricity, shallow geothermal, or recently rather called ambient geothermal, is capable to provide all services mentioned before. Using ambient heat in most cases requires a heat pump to process heat from the air, surface waters, or when it comes to ambient geothermal, the subsurface. In contrast to air and surface waters, the subsurface also offers the option for storing excess or waste heat for a later reuse. So why talking about geothermal energy in urban areas? First of all, we have to consider that the level of urbanization in Europe, currently already at 75%, is way above the global average of urbanization of 55%, and it is expected to continuously increase in the next years, for instance to a level of 85% in Europe in 2050. Urban areas will therefore significantly grow, which offers great challenges to the climatization of buildings to ensure healthy and livable conditions in cities. We therefore need to provide suitable alternatives to fossil fuel boilers and consider to abandon hot waste heat blown out to the streets in summer times. This goes well in line with the latest European policies, such as the Clean Energy Package and the New Green Deal, which aims at clean, affordable and secure energy on the one hand and zero pollution environment on the other. Managing shallow geothermal addresses both aspects in the same catch. Urbanization also brings stress to the subsurface. The urban heat island effect boosts climate warming in cities and expands it to the underground below. If you look, for instance, at the city of Vienna, my hometown, the mean annual surface temperature increased at an average level of +3 degrees Celsius in the past 50 years. A part of climate effects, urbanization raises the level of competition in the use of the subsurface space below cities. For instance, for traffic, energy, or simply for the preservation of a healthy environment. Urbanization and its implications also provide opportunities for new concepts on the use of shallow geothermal, which may help to leave the current niche of this technology inside the heating sector. This implies a shift from the use of shallow geothermal in single-family homes, still dominating the markets, towards so-called low-temperature heating and cooling networks, also known as fifth-generation networks. In such systems, shallow geothermal helps to store and balance heat shifted between different producers and consumers inside the network. Intensifying the use of shallow geothermal energy will require novel approaches in managing its use in urban areas. We might need to move away from linear licensing and management procedures, mostly following the first come, first served principle, and consider instead integrative management approaches, which not just look at the order of application, but also consider their value for heating and cooling, as well as the implication of use on the subsurface environment. Integrative management approaches are dynamic, accounting for current and future interference of individual utilizations, and therefore need to be adaptive. Such approaches more likely follow cyclic management procedures, which rely on a continuous monitoring and adaptable spatial energy and operation plans. Considering all these aspects, it is clear that knowing the subsurface conditions is key for management, Geological survey organizations play a key role when it comes to the subsurface. They collect geoscientific data and provide expertise to various stakeholders, like decision makers, investors, or just the interested public. Some geological survey organizations are even directly involved in regulation as they provide permits for shallow geothermal energy use. Communication addresses various aspects: assessment of resources and limitations of use, sustainability of subsurface use linked to governance, as well as to spatial planning or energy supply strategies. Web-based data portals created and maintained by geological survey organizations represent important interfaces of communication. The Eurogeo Survey Organization provides an additional level to shift concepts and initiatives of interest from regional and national levels to a European level. Due to the growing importance of managing shallow geothermal energy in urban areas, 16 geological survey organizations from 15 European countries decided to cooperate inside the GeoERA Muse project for exchanging and harmonizing relevant topics and concepts. Led by the Geological Survey of Austria, Muse operates between July 2018 and September 2021, having a total budget of around 1.3 million euro. As for all GeoERA projects, Muse has a high share of in-kind contributions at a level of 67%. It is important to understand that Muse is not a project in a classical term, but rather a capitalizing initiative to better integrate shallow geothermal energy into the portfolio of Eurogeo surveys. Muse addresses different cornerstones of the cycled management approach. We collect and harmonize various approaches to characterize resources and possible conflicts related to the use of shallow geothermal. We compare national governance and energy supply strategies and investigate how shallow geothermal could be better integrated. We develop joint criteria for sustainable resource management linked to already existing good practices in Europe. Last but not least, we are collecting and processing geoscientific data in various pilot areas, which feed into a prototype of a modern 2D web information system on shallow geothermal, hosted at the EGDI infrastructure of Eurogeo survey. Of course, Muse also needs to limit its scope. We therefore do not look at technical standards and technological research, neither to market uptakes and business solutions. This is outside of the scope of geological survey organizations. The approach of Muse is strongly linked to urban pilot areas where concepts are developed and tested. In Muse, we address 14 different cities, well distributed across different climatic, hydrogeological, and socioeconomic boundary conditions. The Muse approach intends to assess different ideas and concepts related to managing shallow geothermal energy and provide a harmonized joint framework given by Eurogeo surveys for their future applications. This started at promoting a joint technical language for resources and limitations of shallow geothermal energy use, represented by a set of characteristics related to subsurface conditions. In the moment, we identified 47 of them, which are linked to a joint glossary of terms. This important starting point of our work very much relies on the work of previous international projects, such as Geoplasmacy, GeoERA, GeoCities, or Urbanisation. The set of different concepts for resource description are tested in different pilot areas covering the whole spectrum of data assessment towards modeling and interpretation of data. By doing so, we create resource and conflict maps to be shown at the EGDI services of Eurogeo surveys, which implies further standardization of terms and context shown in the data layers. This is an important and time-consuming step that will lead to role models for geoscientific maps related to shallow geothermal energy use, which can be picked up by other geological survey organizations outside of Muse in the future. But Muse is not just about collecting and distributing data. It also links these data to strategies on management energy supply and environmental protection. In this context, Muse has a long-term perspective concerning the involvement of geological survey organizations into management of shallow geothermal energy use in cities. When Muse will end in autumn 2021, we will set the first cornerstones for direct uptakes inside Eurogeo surveys. The achieved prototype for the EGDI web information system on shallow geothermal energy will be presented to other geological survey organizations not yet involved into Muse. The Shallow Geothermal Energy Days 2021 event, organized by Muse in September 2021, will provide an excellent opportunity to discuss future management concepts to both national as well as international stakeholders. A joint knowledge repository on shallow geothermal, which was initiated in Muse, was designed to be flexible for expansion and adaptation in future initiatives inside Eurogeo surveys. Among others, it hosts the catalog of workflows for mapping resources in conflict of use related to urban shallow geothermal. We also want to continue our joint work under the umbrella of the aimed Horizon Europe Coordination Support Action, CSA, which is expected to start in 2022. CSA funds might offer the opportunity to further expand the EGDI prototype of a web-based information system by integrating data layers of already closed international projects on shallow geothermal energy. Moreover, the CSA call may give an opportunity to strengthen and expand the network on shallow geothermal energy use inside Eurogeo service and beyond. We believe that Muse sets an important first step for the promotion of sustainable and efficient shallow geothermal energy use for greener and healthier European cities. Having all this said, I would like to thank you for your interest in Muse and invite you to follow this project on our website and social media channels. Let's join forces to support geothermal energy, a strong all-rounder inside the energy sector.